All right. Is it coming up? Remember when you were in Algebra 1 and they kept throwing something at you, they kept throwing this at you. They kept throwing f of x equals y. Do you guys remember that? All right, so all that means is that x literally means that you have an ordered pair, some x, comma, some y. That's all it means. That's all it means. So if I have this and it says f of 1 equals, I want to know what the y value is when x is 1. So I look down, x equals 1, and I see where I am defined. By the way, this is the x-axis, see? And this is the y-axis. So I'm looking down when x is 1, and I see that I am defined. Bam, right there. I have a nice solid point. What is that y value? Yeah, and there it is. That is it. That's all I want. See? Nothing crazy. Let's look at number 2. Number 2 says f of negative 4. So that means when x is negative 4, what is the y value? So I'm looking at negative 4. Now I want the y value where you're defined. Be careful. That right there that you see at negative 4, negative 1, that is called a hole. And the technical term is called a removable discontinuity. Removable discontinuity. We will talk about that when we get there. We are not there. Where are you defined when x is negative 4? Do you see a point anywhere? At 2. That point is negative 4 comma 2. So f of negative 4 is simply 2. And that's it. Let's jump to number 3. It says f of 5. So I look at x equals 5, and I see that I have a point at what y value? 3. So f of 5 is simply 3. Have I confused anyone so far? Okay, good. Let's go to number 4. It says f of 1. I look down, x equals 1, and even though I don't have a solid point right at 1, I do, look, I am continuous. What is the y value when x is 1? 0. And there it is. That point is just trying to tell you about a singularity or right at that moment, especially if you're not like at that 2, negative 2. So you have a hole at 2, 2. It's just saying that when x is 2, the y value is negative 2. All right, let's go to number 5. Are we having any issues so far? Perfect. At 3, look at x equals 3. If I look down x equals 3, I notice that I just have a hole at 3, negative 2, and nowhere are you defined. There is no y value when x is 3. So the perfect word for f of 3 is to say, it starts with letter U, undefined. And that's it. F of 3 is undefined. You are not defined anywhere. When x is 3, there is no y value. Does that make sense to you guys? Perfect. Look at number 6. Number 6, how's number 6 related to number 5? All these graphs are called piecewise functions because they're in pieces. Sometimes they call this a restriction. So I'm going to put restriction in quotes. So all this means is when x is less than 3, the output is always 5. When x equals 3, the output is negative 6. That's actually a point. This is whenever you see an equal sign for just one value, that's usually 99.9% of the time is a point, unless you take a course called complex analysis, then it's going to be something else, but we'll get to it when you get to it. For x greater than 3, it's a negative x plus 8. I'm going to behave like that expression for x greater than 3. Don't worry, we'll talk about how to graph in a little bit when we get to it. This says find f of 7. Well, f of 7, you're not going to look, let me erase all 3 of these. You're not going to look at this one up here in the top because that one says it's only 5 for values x less than 3. Remember in math, if it says less than, that means you go to the left. So x less than 3 means values like 2, like 1, like 0, negative 1, negative 2, negative 3. All those values are less than 3. I know in science, the further left you go, the magnitude goes higher. That's not less than, but that's different. In math, the further left you go, that's smaller. Cool? Okay. X equals 3, that's just the point. You're out. 7 is to the right of x equals 3. So if you have a number line and you're here at 3, 7 is way over here. See? So, and 7 is larger than 3. So I'm focused just on that expression, the negative x plus 8. Does that make sense to you guys? Okay. So here we go. I'm going to write f of 7 is equal to, and then from all 3 of these, I'm going to use the bottom one because that's the one that says x greater than 3. So negative on the outside, in parenthesis, I'm going to put 7, close, plus 8, Negative 7 plus 8 without a calculator is 1. That's it. Done. F of 7 equals 1. Are we okay so far? Nothing crazy, right? Okay. Let's go to the next one. Check it out, guys. They're trying to trick you on purpose. This one says f of 5. The top expression is for x less than negative 3. We're not using that. Look at the bottom expression. It says for x greater than 5. Can I use that one? No. Why can't I use that one? Perfect. This says x greater than 5. I can't use this model unless it's for x greater than 5. And this says equal to 5. So for this one, what word am I going to use? Undefined. Good job. You guys must be GT. Does that make sense, guys? Okay. Let's go to number 8. Please stop me. If something doesn't make sense, guys, please stop me. I can usually read faces, usually. The face that you guys usually make when you don't understand is this. You're like... That's usually the face, but you know, sometimes you guys do this, and if you do this, I can't tell. If you do that, I can't tell if you're daydreaming, if you're focused, or if you're bored. Like, how do teachers tell when you do this? You notice, what am I? Bored. Yeah, see, I don't know, maybe. All right, here we go. Don't freak out with this, guys. Don't freak out. What this means is, as long as x does not equal 2, use this one for always. That's what I mean. Let me put it in words here. As long as x does not equal 2, use this specific expression. That's all it means. And then the x equals negative 4 means when x equals 2, use negative 4. So it says f of 2. Well, check it out. You're using 2 for this one. So the output's just going to be negative 4. Don't worry, I'm going to test you. What if I said I want f of 1? Am I going to say negative 4? No, it says right here, look, as long as x is not equal to, oh, wait, that's not a 2, that's a 1. Okay, use this specific expression. Oh, okay, I'm going to use this top one. So if it was f of 1, you go 1 minus 4, close it squared, minus 6. 1 minus 4 is negative 3. Negative 3 squared, negative times a negative is a positive, 9. So negative 3 times negative 3 is positive 9. 9 minus 6? 3. So if I were to ask f of 1, you would have told me 3. Does that make sense, guys? Perfect. So there it is. You got 2 examples for the price of 1. All right, let's keep going. Number 9, and let me know if I go too fast. If I go too fast, let me know, guys. Number 9 says find f of 0. When x is 0, what is the y value? Negative 6. That's it. See? That's it. By the way, guys, these come out all the time in the SAT, ACT. What are these called? It starts with the letter P. Piecewise functions. They come out all the time in the SAT, ACT. This one says f of negative 6. Oh, child, the negative 6 number is not in here. Which one do I use? Okay, focus on your restriction. That negative 6, am I using the top one, the middle one, or the bottom one? The top one. It says x less than negative 3. Negative 6 fits in that domain. All my x values smaller than negative 3. Negative 4, negative 5, negative 6, negative 10.5, negative 11.3. All of those. Cool? I go to the top one. I go f of negative 6 equals, parenthesis, negative 6 plus 4, close it, square it, plus 3. Child, I need a calculator. No, you don't. Negative 6 plus 4 is negative 2. When I taught my little sister, because she had a hard time with negatives and positive, I just told her whenever the signs are opposite, just find the difference and find the difference, and whichever one's larger, keep the sign. The difference between 6 and 4 is 2. The 6 is larger, keep the sign, negative 2. Negative 2 squared, 4. Negative times the negative is a positive. And 4 plus 3, there it is. So f of negative 6 is just 7. How do we feel? Okay, let's keep going. And did we reach our first? Okay, put your pencils down. And this is where we first start having issues. It's really simple, guys. It's not bad at all. It's not hard. All of you guys took Algebra 1. Do you know how to use your point-slope formula? Okay, so remember from Algebra 1, what would you do? You would go like 3x plus 2. You would go to y-intercept of 2, and then you would go slope 3, up 1, right 1. And then what did teacher say? If it's a positive, you go up, right, and if it's a negative, you go down, right, or something like that. Okay, we're just going to do a little hack. It depends on your restriction, whether we go up or down. So all you got to do when you read a graph just like you read a book, left to right. If it's a positive slope, I better be going uphill, left to right. If it's a negative slope, I'm going to be going downhill. So don't worry about like, oh, which way should I? Just if it's positive, uphill. If it's negative, downhill, left to right. Here's the restriction. X is less than -4. Here's where I start. Start at your restriction. So I'm going to start at -4. Don't write this down. Just listen. Don't worry. I'm going to give you guys time. What is -4 times -4? 16. And what is 16 minus 15? 1. So I'm going to go to -4. That's what I did. In case you're wondering, child, what are you doing? It's like making a table. I plugged in a -4 and I got a 1. See? So -4 and I go to 1. Don't worry, I'm going to give you guys time to write. So don't write this down. Just listen. And I'm going to put a solid circle. Why did I put a solid and not an open? Because of the equal sign. Does everyone know about that equal sign down there? Okay, now look what it says. It says, don't write this down, just listen right now. It says x less than equal to -4. So I'm not defined for values that are positive, or not positive, but values to the right of -4. This curve is just defined for values to the left of -4. Does that make sense? So from that point, look at that slope. That's a -4. So I have two options. I can either go up 4 left once or down 4 right once. Which one is the better option? Which one's the right option? Don't write this down, just listen. I can either go up 4, 1, 2, 3, 4, left once, because I better be going downhill, left to right. Or I can go down 4, 1, 2, 3, 4, right once. There's one that's correct and one that's wrong. Which one's the right one? Which one's the wrong one? This one's the correct one. Why is this one the wrong one? Yeah, you're not defined for anything greater than -4. You're only defined for values that are to the left of -4. My domain for this top function is all values from -infinity to -4. Does that make sense? So that's how you decide, like, Chop, my teacher told me I should be going down and right. This is wrong. Like, no, it just depends on the situation. This, I'm restricting my equation, my domain. I'm restricting my domain. So I have to go up left, because that's the only way I can go downhill left to right. Does that make sense to everyone? Okay, go ahead and start writing down, guys. Your first point's at -4, 1, and then go 4 up, 1 left. 1, 2, 3, 4, 1. With your colored pencil or whatever you may have done, go ahead and put the arrow like that, forever like this. Make sure it has an arrowhead, it goes forever. All right, here we go. Don't worry, I'm still going slow. I haven't done anything crazy. I'm going to get a different color. So if you have colored pencils or if you have a different colored ink, or now's a good time. If you want to have your notes colored and all that. I'm going to circle this one in sky blue. And I'm going to go slow, don't worry. And I see that my restriction equation says it's only for x greater than 3. So I'm going to put in that 3 in there first. What's 3 times 3? 9. And 9 minus 4? 5. So go to 3, 5. Open or closed? Open or closed? Open, because I don't have a equal sign. Yeah, equal sign. Greater than equal to sign. What's my slope? 3. So I'm going to go up 3 and to the right 1. 1, 2, 3, right 1. So I have a point at 4, 8. 1, 2, 3, right 1. Boom. And there it is, guys. How do you guys feel? Hit me with questions. Do we have questions? Ask. It is a safe space.
But could we just substitute values like integers as well?
Yes, you could have just gone, you could have plugged in a 4 to see where you're at. 4 times 3, 12 minus 4, 8, and you would have been there at 4, 8, and then just connect. Yes, I go by my restriction. You see how it says x greater than 3? I plugged in that 3 immediately right there into the x value. 3 times 3 is 9, 9 minus 4 is 5, and I put my open circle. And then from there, I just use my math algebra 1 skills from y equals mx plus b, and I saw that the slope was 3, and I just went from that point, up 3, right 1, up 3, right 1. You could also do, you could plug in random integers to the right of 3, or 4, or 5, or 6, and do that as well. Whichever one you guys like. It does not matter. All right, let's go to number 12. Let's see what we got. We're going to go slow. All right, here we go. You guys ready? So what do I do first? I'm going to plug in that restriction. I have an equal sign, so that means I'm going to start with that solid point. So at -1, plug in a -1. What's -1 minus 2? -3. So go to -1, -3, put a point. Why am I making it a solid and not a dot and not an open? Because it's equal to. What's my slope? Positive or negative? Positive 1. Sorry, I should have said positive 1 or -1. It's positive 1, so I can't go up 1, right 1, because it says x less than -1. But instead of going up 1, right 1, I'm going to go down 1, left 1. Down 1, left 1 point, so I have a point at -2, 4. Down 1, left 1 point, so I have a point at -3, -5. Down 1, left 1 point, so I have a point at -4, -6. And then connect them. Make it go forever like that. Are we okay? Perfect. We're still not done, guys, so I'm going to change my color to sky blue, or I don't know, whatever they call this color. I just think it looks like the blue of the sky when you look up, so I call it sky blue. And I'm going to go right to 5. Chav, how do I start? Start at your restriction. You see how it says x greater than 5? So start at 5. What is 4 times 5? And 20 minus 22? Yeah, you can say it, guys. Say it loud and proud. -2. So plot 5, -2. Open or closed? Open. What's my slope? Yeah, what's the slope of that expression in sky blue? 4. Yes, miss. Because I don't have an equal sign right there. It just says x greater than 5. So at 5, you're not actually defined. So because you're not defined, you put an open circle. Good question. Slope of 4, guys. Start at that open circle. Go up 4, right 1, because you're going uphill. 1, 2, 3, 4, up to the right 1. So you're at 6, 2. 1, 2, 3, 4, right 1. So you're at 7, 6. And that's enough to get this line here. And there it is, guys. You just graphed a piecewise function. How are we feeling? They're not bad, right? Do you guys remember this from last year? Did you guys do some of these? Like somewhere, or like, do you remember them sometime, at some time? Somewhere? If you don't remember, they do come out, guys. Maybe you saw them on the PSAT, but they come out. How many questions are there? Not a lot, but I guarantee you'll at least see one, on the ACT. And on the PSAT, they have like 2 different sections of math. I'm sure that it comes out at least twice, maybe even 3 times. But on the ACT, you'll see at least one piecewise. All right, question 13. Graph the following function. We're going to go slow. It says, look, I'm going to do this one in red. It says that it's always 2, so that's going to be a horizontal line, like y equals 2. It's always 2 as long as x is less than or equal to -2. So go to -2, 2, put a point, and it goes forever to the left with a y value of 2. If you want, you can put points at -3, 2, -4, 2, -5, 2. But it looks like that, guys. Cool or not cool? I'm going to go to sky blue. For x greater than 4, I behave like -x plus 3. So I'm going to plug in a 4. What's -4 plus 3? No, you can say it. -4 plus 3? -1. So go to 4, -1. Open or closed? Open. What's my slope? -1, so down 1, right 1. Down 1, right 1 point, down 1, right 1 point, down 1, right 1 point, down 1, right 1 point. Let me know, guys, because sometimes I go really fast. And notice I'm going down. It's a negative slope, so I'm going down. Yes. Yes. As far as I'm concerned, these functions are in terms of x, so these restrictions would be in terms of x. If they were to tell you f of y, then you would have an expression in terms of y, and your restrictions would be like y equals. But we're not at that level yet. We'll get there when we get there. So they're always going to be like that.
So now we're never going to have a vertical line?
Not yet. Not yet. When we start talking about circles and ellipses, we will, but not yet. How do we feel, guys? Okay. How do we feel? All right. This is Mr. Quinones, guys, in case math life. All right, here we go. For x less than or equal to -5, you're always -2. So go to -5 from the x value in the x-axis and go to -2. Put a solid circle and go forever to the left at -2. There it is. I'm going to change to a sky blue. For x greater than 0, go to the y-intercept -1. Open circle. What's my slope? +5. Go up 5, right 1. 1, 2, 3, 4, 5, right 1. So you should have a point at 1, 4. 1, 2, 3, 4, 5, right 1. Another point at 2, 9. And it goes forever to the right. How are we feeling, guys? Oh, yeah, please ask. Hit me.
How do you like restate about the slope for the second one?
Yeah, of course. So all these are linear lines. So they're all written in terms of y equals mx plus b. So I see that 5 is your m, and I see that -1 is my y-intercept. So immediately I went to 0, 1. But you didn't have to do it that way. You could have just used your restriction. See how it says x greater than 0? You could have plugged in a 0 in for x. 5 times 0 is 0, 0 minus 1 is 1, or -1. So you would have plugged in 0, -1, which would have been there anyways. And then that 5 in front of the x, whatever's in front of the x is your slope. So I went up 5 to the right 1, up 5 to the right 1 from the initial point. Yes, ask.
So let's say, hypothetically, the slope was the fraction was 5 over x. Because x is 0.
Oh, it's not going to be 5 over x, and then it's no longer linear. That's you're talking about inverse function or 1 over. No, you'll have nice like 2/3 x or something. Maybe I would have had a -5x. If I would have had a -5, instead of going up, I would have gone down and to the right. Any other questions, guys? Hit me. These are good stuff. This is good stuff. Is all this being explained clearly? Are we getting it? You're not just telling me that just to tell me that. Because I know some of y'all's games, teachers will ask, you get it? And you're like, And then it's like 5 seconds later, the teacher goes away and you go to your friend, hey, how do we do that question? So I know. Okay, so we're good right now, right? Okay. Relax. It's not that bad. It looks tough, but it's not. You just have more restrictions. That's all it is. All right, here's how we're going to start. Oh, you want to?
I'm just going to say, so usually it's only restricted on one side, and I'll just have a random point.
Yeah. So you know what? Let me do number 15, and then maybe you'll do, not number 16. Maybe you'll do number 17. We'll see. No pressure, miss. All right, so here we go, guys. I'm starting with my restriction equation. I'm going to go really slow. I'm going to put that one in red. So I'm going to start at -2, because this is, okay, before I even go, because I don't want you guys to become a robot. This means, right here, this is my domain restriction. It's telling me that my x values are between -2 and 1. The -2 is not included because I do not have an equal sign. Does that make sense? So put that in your notes, that's what it's telling, that to only graph -2x plus 3 between -2 and 1, between x equals -2 and x equals 1. All right, here we go. I'm going to plug in a -2 in for my x value. So I'm not using any calculator or any technology. -2 times -2 is a +4, and 4 plus 3, 7. So I'm going to plot -2, 7. Go to -2, 7, and put open or close circle. An open because you don't have an equal sign. Next, my slope is -2. So that means I'm going downhill. So I need to go down right. Child, why are you going down right and not up left? Because I'm going between -2 and 1. So I need to be going to the right so I can get to x equals 1. Does that make sense, guys? So I'm going to go from my open circle, I'm going to go down 2 to the right 1. So let me see. -2, 7. I'm going to go down 2, 1, 2 to the right 1. So I have a point at -1, 5. And I'm going to keep going until I get to x equals 1. 1, 2, 1. I have a point at 0, 3. Sure enough, that's my y-intercept. 1, 2, 1, bam. So I stop at 1, 1. I put a solid at 1, 1 because there's an equal sign there. and I connect them. And there it is. That's all your graphing for that part right there. Are we okay so far? All right, I'm going to go to sky blue. I'm gonna pick it up at x equals 1. So I'm going to go to 1. I'm going to plug in a 1 in here to my expression. Negative 1 plus 3 is 2. So go to 1, 2. Open or closed? Open. Put on open. What's my slope? Negative 1. So I'm going to go down 1, right 1. Down 1, right 1 point. I have a point at 2, 1. Down 1, right 1 point. I have a point at 3, 0. Down 1, right 1 point. I got a point at 4, negative 1. Down 1, right 1 point. I got a point at 5, negative 2. Down 1, right 1. Be careful. At 6, it's not a solid. It is a open. 6, negative 3. Are we okay? All right. Connect them. And there it is. This one's open. This one's open. How are we feeling? I think number 16 was a hiccup because I have not seen another question come out like this on Delta. All these questions are coming from Delta Math, and I think it was a hiccup because I have not seen another student come up. I have not seen from all the questions that I've seen this over and over again, but I'll treat it just like the others. I'm going to circle this one in red. At negative 4, I'm going to plug it in. I'm plugging in that negative 4 into my x. Negative times a negative is a positive, and positive 4 plus 1 is, what's positive 4 plus 1, guys? 5. So go to negative 4, 5, and put a point, because this one has an equal sign. Are we okay? My slope is negative 1, so I'm going to go down 1, right 1. Down 1, right 1 point, 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 all the way, I passed it. All the way until you get to negative 1. At negative 1, put an open circle and connect it. Don't worry, that open circle is going to be filled in with the next one, and the next one is going to be the same equation anyways. If I plug in negative 1 for the one in sky blue, I'm in the same location because it's the same expression. Negative 1, negative times the negative is a positive, so I get a positive 1 plus 1, which is 2, so negative 1, 2, and that's an equal sign. So I fill in that hole, and I keep going with the slope of negative 1. Down 1, right 1 point, down 1, right 1 point, down 1, right 1 point, all the way until you get to 3, until 3, negative 2. And that one's solid. And there it is. Why does it look like that? Because it's the same expression, it's the same line. How are we feeling, guys? Feeling pretty good? Okay. Did you want to try number 17? Yeah.
So let's say if you just didn't want to like do the graphing that way, could you just find the points for like the restrictions and then just
Connect them because they're linear? Yes. You want to do that? Do you want to? Okay, maybe it's too soon. I'll do it. Okay, try. So what's your name again, miss? Ray. What Ray was saying is, can I just find the restriction on both endpoints of my domain and then just connect them? And like, yeah, you want to do that? That's fine.
It's tall.
Oh, is it?
It's okay. How do I change colors?
Oh, on the side here, you see these colors?
Okay. Do I need to explain or can I just do it?
See if you can explain it and if you think try your best. Try your best.
Okay. So all I'm going to do is I'm going to plug in the restriction into the equation. So 2x, I got 1, 4. And then I'm plotting, or that's an open. How do I erase? Oh. And that's an open circle. And then I'm just going to plot the graph all the way.
Am I defined for values greater than 1?
It is not. You're right.
So instead of going that direction, you go the
Opposite.
Yep. It's not a hard reset, guys. It's just a little You know, instead of, because I know why you're used to that, because your algebra one teacher told you positive, but just ask yourself where you define and then just adjust accordingly.
I'm gonna do the smallest one first. So if it's anywhere, it's a horizontal line, so it'll be anywhere in between 1 and 4. So it's gonna equal 6. It's closed circle. Oh.
Perfect.
And then for the final one, I'm just gonna plug in the 4 into the equation. Negative 8 plus 13 equals 5. So 4. And then negative 2. Right? Yeah, okay.
Just connect them with an arrowhead. Perfect.
Okay.
Ready to go, miss? Yay. Thank you, Ray. Did I call your name right? Yeah. My last names?
Yeah.
You don't want Vega?
No,
Okay.
I just didn't know if you prefer last names.
I prefer last names, but if you
I'm cool
don't,
with Vega.
okay, cool. And there it is, guys. What do you guys think? Not bad, right? Okay, let's keep going. Let's see what we got. Okay, so remember, this just means as long as x is not equal to 2, you graph this expression. But if x equals 2, you graph that. So the easiest one to do is, I'm going to do the point first. 2, 1. 2, 1, point. Done. All right, for the other one, I'm going to graph the 3x minus 6. As long as x is not equal to 2. So you have a hole at x equals 2. So I'm going to go ahead and do this one in purple because I see that I underlined it in purple. Or whatever color you want to call this. So I'm going to go to negative 6, point. And I'm going to do my slope is positive 3. So I'm just like in algebra 1 again. I'm going to go up 3. 1, 2, 3, right 1, point. 1, 2, 3, right. Be careful. At 2, you don't have a point. So you make it a hole. 1, 2, 3, point. 1, 2, 3, 1 point. So I have a point at 3, 3. I have a point at 4, 6. 1, 2, 3, point. I have a point at 5, 9. And here's how it looks. Make sure that you write that you have a hole at 2, 0. We're okay, guys? Okay. Let's go to number 19. Nah, not number 19. Well, it doesn't matter. Let's do 19. And then we're going to do a few examples with you guys, just so you can see that we didn't just randomly pick. What's up?
So because the open circle is both full and just like greater or less than, do we need to also specify when it's greater or less than, or just we specify when it's
What do you mean by greater or less than?
like,
'Cause-
you know how you do an open circle?
Oh, yes, got you. The reason, I got you. So what you're saying is, this is like saying x is less than negative 2 or positive 2, and x is greater than 2. This is the easier way of saying it. The other one is interval notation, negative infinity to comma 2, union 2 to comma infinity, because it means all points except 2, see? Okay.
Like if we were just like just for the less than equal to, we also need to specify like this is. I don't know what I'm trying to say.
Yeah, I know. I think I know what you're trying to say. No, because this is like saying that, like, this is saying my domain is all real numbers except 2. And then when it is 2, do this. You know what I mean? So, yeah, so I think you're good on this one for that. Yeah. What she's trying to say, guys, is like on the others, you see how you have a restriction like this with intervals? This is saying all values except 2. So from negative infinity all the way to 2, union from 2 to infinity. So everything except the value 2. So yeah. All right. Let's do one more. Yeah, you guys choose 19 or 20. That way you can go right into delta so you guys can see what's up. Yeah, 20? Okay, number 20. So what this says, so put it in words. Domain is all real numbers, just for what I'm circling. Because the domain for f of x is all real numbers. Domain is all real numbers except x equals -4. Just for what I'm circling. Because the domain of f of x is all real numbers. This is f of x. Just for what I'm circling. That's what this means. Are we cool, guys? Okay, so here we go. As long as I'm not -4, I'm going to plot negative x minus 4. So I'm back in algebra 1. I'm going to my y-intercept, -4. My slope is -1. So that means I'm going to go up 1, left 1 point, up 1, left 1 point, up 1, left 1 point. But be careful. Right at -4, you have a hole. Up 1, left 1, hole. Up 1, left 1 point, up 1, left 1 point, up 1, left 1 point, point, point. Same thing, down 1, right 1 point, 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 point. So it looks like this. And it goes forever that way. And it goes forever. So your domain, and notice you have a hole. Hole at -4, 0. When x equals -4, what is the output? -5. So when x is -4, the output is -5. What's up, Ms. Henderson? You had a question? Yes. The first thing I did, I was like, I remember when I was in Algebra 1, we graphed these lines all the time. Mx plus b, b. And then I saw, well, that looks just like y equals -x minus 4. So I plugged in my y-intercept of -4 right there. I don't know why I said it like that, sorry. And then from there, I did my slope of -1. So I just went up 1, left 1, up 1, left 1. You could also choose values. You could also make a table if you want. Did that make sense, Ms. Henderson? And then just remember that you're not defined at -4. So just remember that. How do we feel, guys? Okay, so one last thing. Hold on, one last thing, and then we'll set you guys loose.